Okay, my name's Kevin Daivis, and I'm the agronomist for the South Central NRCS team, which encompasses Zilla, Yakima, Goldendale, and Prosser. And I was kind of tasked today about crops and maybe some agronomic applications. And I stuck it basically to agronomic applications because we'll hit the crops as we get in there. So when you're looking at agronomic applications, you want to apply your nutrient to meet your crop needs, to make it economical and do so in an environmentally safe manner. And the slide Nicole had up earlier, you want to target the right source, the right rate, timing, and place. So you want to match, when you're looking at doing that, you want to match the type of manure you got to your crop needs and capabilities. Are you doing a one-time application to corn, or are you trying to apply your total nutrient need to alfalfa with a solid manure? I mean, that's probably not going to work. 8-ton alfalfa is going to pull close to 400 pounds of nitrogen, and you run the math. That's a lot of manure at one time, and more than likely wouldn't make it. So that in looking at the source, you know, your manures, every pen's got a different recipe of what you're using for bedding, what your cow's using for feeding. Testing those sources and knowing what they are. Commercial fertilizer, taking into account your organic matter, the decay or mineralization from previous manured crops or green manures, and then credits from previous crops, legumes. There's also, I didn't put it in there, but also irrigation water, which can be a substantial amount. Typically, that's not so much an issue here, but if you're irrigating from a well at 10 parts per million, which is sure the favorite number for the day, you could be looking at putting on close to 80 pounds of nitrogen annually through your irrigation water, just strictly without the manure. Applying the appropriate amount to satisfy the crop needs is creating a crop budget. And I'm just going to talk about the applications at this point. We've already gone through your resource concerns, your leaching potentials, the phosphorus index, and so you determine whether you're going to do your application on nitrogen base or phosphorus base. And for most cases, we don't really have a transport factor in the Yakima Valley, so we deal mostly in nitrogen. The NRCS, we're required to do the nutrient budgets based off the land grant university guidance. And for the most part, I pulled for this presentation, I pulled like 5 different alfalfa guides from across the United States. Every one said something different. You read down into it. It deals with yields, it deals with climates, but on a per ton basis, it all goes back to the 50 to 60 pounds of nitrogen per dry matter ton of alfalfa. So, utilizing a good guide, sticking with it and following it. We have what's called our Tech Note 17, which lists all the crops that they've gathered the data from the land grant universities. I didn't put it on here because I'm going to pass this copy around because you'll soon see why. You can't read it. It's crammed into such a small space. You can't read it. I have, like I said, there's the website for it, and if everybody's email is on that sheet, if you're interested, I can email the PDF, but if you want to send that around, that's fine. Soil test, again, as per land grant university requirements in your nutrient guide. Typically, for nutrient recommendations, we look at the top foot. There are some nutrient guides that say corn you sample to 2 feet, and that there's not a fertilizer application until you look at the site-dressed nitrogen time. So you're starting to get into the timing. Consistency. They talk about the report card test. Ideally, you'd like a test before you apply. We don't have the rainfall. We're looking at a 7 to 10 inch rainfall annually, probably 3 of that in the winter time period. So if you had a fall sample, the numbers aren't going to change drastically if you use that for a spring sample for your application. Every lab has to meet the performance assessment program, and that's a web page again that lists all the labs locally that can run those tests that we would accept as credible. We do have, Keith mentioned it, and the government's kind of pushing the soil health program, which is more an organic matter base, and those guys are pushing soil tests they're odd to me, but they are carbon based. So they're basically soil tests is coming back that you have happy, healthy soils or not. Those, unfortunately, where some people may think those are all right, we can't use those with the land-grant university guidance. When you're creating a budget, you look at all your credits, organic matter mineralizations. Typically, native soils in the Yakima Valley are between 1 and 1.5% organic matter. Manured soils are going to climb up there. I've seen fields up to 4%, which is quite high considering the native is 1. So I've also seen tests that show mineralization rates that range from 20 pounds to 100 pounds. If you stick with the number and be consistent, you're counting for it, and I mean that's pretty much the best that you can do. And in my time in dealing with it, 20 pounds was used, so every time you see a percent organic matter, you're figuring you're going to get 20 pounds of nitrogen out of it. Legume credits, if you're plowing down your alfalfa, if you're and that 40-pound number is looking at about 2 plants per square foot by the time you take it out. The 80-pound is more up about 5, and some tests have shown that legume credit of well over 120 pounds. So you need to take that into account. Previous manure applications. 50% of your manure, or your applied manure is available. 50% will be available later. You got 30 years of history. That's a lot of manure to account for. Years ago, a soil scientist from WSU, Bob Stevens, told us that you can pretty much count that what you're applying is what you're getting. So if you're applying, if your application is 400 pounds of nitrogen, you're getting 400 pounds of nitrogen. If you come to the NRCS, we're going to tell you you're getting 200 pounds of nitrogen. You get 200 pounds. You get 200 pounds for mineralization. So it's just a different way of accounting for it, but it needs to be done. Irrigation water, like I said, 10 parts per million. If you're irrigating from a well, typically our water rights are 3 feet. So if you're applying your basic water right, you're looking at 83 pounds annually. And when we do the budget, we all sources. The other thing, you get into when is the crop going to use them? Am I going to apply my the manure for my triticale in the fall when I can disc it in? Is that going to be adequate? But you look at, and now this is a growth curve for winter wheat. But a study showed that 30% of your nutrient uptake is going to come in the fall. So after your corn's off, triticale is going to use between 150 and 200 pounds of nitrogen, so you need to have about 30% of that in the fall and be able to come back to it in the spring. If you're looking at split applications within the next couple of weeks, that stuff is going to wake up and really take a drink. Corn, similar instance. This is vegetative and in leaf stage. So most of the nitrogen application or the nitrogen uptake in your corn is going to come just about the time it starts to tassel. And so understanding what you apply, how long it takes to convert to the nitrate, it helps you target to get that out there. It's not sitting out there at a time when it can be leached. It can be blown off with wind, dust, eroded with water. Keeping nutrients in the root zone where your crops can utilize them and eliminate the off-site movement. Irrigation water management is probably going to be one of the bigger keys to deal with this. Just the fact that that's the avenue that stuff is going to leave from. If you got a real irrigated field, we're going to 50%. Rule of thumb is it takes twice as much water at the beginning of the field as it does at the end to get your irrigation amount. So you're going to be running water off, and that's going to carry sediment. A wheel line on 24-hour set typically is going to apply about 4 inches of water. You're going to fill up that soil profile in 24 hours. And then once that profile's full and wet, water's there, you've created the avenue to leach. Typically pivots in the spring and fall is the crucial time there. In the middle of summer, those things barely put out enough water to keep a crop growing. Split applications. Apply your manure when the crop needs it. Does alfalfa need 400 pounds of nitrogen in the spring? No, it doesn't. It's a legume; it'll make its own. If you supply it with nutrients from manure, chances are pretty good the nodule formulations aren't going to happen on the roots, and it's going to be a continual thing. But I mean, it's a great utilizer of nitrogen, and it helps with the P and K as well. But so in the split applications, you try and apply it in a timing after every harvest. Whatever your nutrient budget works out, you try and target that. Equipment calibration, and this is kind of where we're going to take this talk. Is how much are you applying? You've soil tested your field. You tested your manure. You've determined that you need fertilizer. So how much are you sticking out there? Some people, that's where their nutrient management stops. Some people are out there. I'm not. You think back, when's the last time you calibrated your spreader? So we're going to look at. We'll start off with the center pivot, and kind of the way we're going to do this. There's two different ways I'm going to talk about it. The way you do a liquid and the way you do a solid are pretty much, whether you're doing a liquid and a pivot, whether you're calibrating a big gun. But typically, and the only number they're real is the soil or the nutrient test from the manure, which is also part of your exercise this afternoon. But if you're applying 3/4 of an inch of your legume and it tests 3 pounds per 1,000 gallons, how much nitrogen have you applied? And so some fantastic numbers that should just roll off the tip of your tongue. 1 acre inch is 27,154 gallons of water. And you've applied 3/4 of an inch, so you've applied 20,000 gallons, or 20,365 gallons of effluent out there. Your test is in pounds per 1,000 gallons, so you got to go through the conversions. So you're basically putting on 20 1,000 gallon units out there at that 3/4 an inch times your rate. That's a 63 pound application. And then at this point, depending on where you've gotten your sample from, in the past when I've worked with producers on this, we have in Whatcom County they had one. Lori bought me one when I was in Sunnyside. It's called an Agronomic. It's a quick, easy way of determining the ammonia in your manure, and it takes bleach and it creates a gas and it reads off of pressure. And oddly enough, it's pretty accurate. I ran both units in Linden and Sunnyside, and I side-by-sided them with some manure tests. Not near enough to what a university would say a statistical analysis is, but enough to know that it's pretty dang accurate. So if you've taken that test right where it hits the ground, most of your volatilization, not all of it, but a majority of it, you've run it through your pivot, you've exposed it to the atmosphere, you're going to get a pretty close number of what you're actually applying. If you're taking your sample at the pond where it's mixing, then at this point you would want to figure in, Nicole said, 40%, and it could be as high as 60 to 70%. So you've spent the money to apply the manure. You want to do the best you can to capture all that nitrogen. There's no reason to go back out and spread commercial when you've already put it out there once. The tank application calibration. Just some information. We're assuming a 4,000 gallon tank. Manufacturer recommendation says it's most of the time that thing's only going to be 85% full. And that's, I mean, what rate does your pump fill the tank? How does it suck it up? You know, you're not going to get 4,000 gallons in a 4,000 gallon tank unless you spend an hour doing it. So you look at a couple of different ways to determine your rate. You can either measure the area that one tank applies, or you can use coffee cans. Any kind of can that has a straight edge, or straight down the side. So when you stick a ruler in there, a 1-inch application is a 1-inch application. If you're looking at something with like the coffee cup there, you stick a ruler in that, 1 inch in the bottom is not going to be a 1-inch application. Assuming our spreader, we're spreading 12 feet. That setting 4 coffee cans 3 feet apart is not a standard. The more you set out, the more accurate you're going to be. The one nice thing about setting cans out over any piece of equipment that you're doing is you kind of always see the uniformity of how it's applying. Sometimes they're heavy in the middle, they're light on the end. It can help you gauge overlaps, in which case you would be accounting for that. So you set your cups out at a known speed, RPM, PTO setting. You go across and you measure it. You record it, and then to adjust it is going to be speed, RPMs, and maybe you can open the valve on the tank more. But so assuming that our cups collected that much, and it gives us an average of 0.68 inches. And it's the same inches times gallons per acre inch gives you the out there, and at that 3.1 pounds per 1,000 gallons, that's a 57-pound application. So this is all, we've calibrated these numbers. If you're doing this at the end of the field, well, we've missed the point. This would probably be a pretty dang close rate if I was applying after every time I harvested my grass or my alfalfa. Because first cutting hay is going to pull 2+ ton, and it kind of goes down gradually. And at 50 pounds per dry matter ton, your first cutting you're looking at 100 to 150 pounds. Seconds 100, and it goes down. So you would want to adjust your variables to hit your rate in the beginning. So when the Department of Ag comes out and says, how much manure did you apply? You don't just, you give them the number, and you give them the most accurate number you can. So the more cups you set out, the more accurate that's going to be. The better counting you can do with it. So if you're measuring it out, that one tank's covering 1/4 acres at 4,000 gallons at 85% full is 13,000 gallons an acre. And the math works itself out, again, the same way pretty much for all liquids. Solid manure, it seems simple, but it depends on what you have. You throw a tarp out across the field, drive the truck across the way the tarp, figure out how much of an acre that tarp is, and you can come up with a rate. I must have went back. A 10 by 10 tarp is 100 square foot, and this is a sample. This is an actual sample that was taken out of, I think, is a Kansas State study. I'm not exactly sure where I got it, but so they're actual numbers. 110 pounds of manure. What have you got to weigh that? You can take it across the scales. Your trucks go on, borrow your wife's bathroom scales, which we did. Not a recommended thing, because it costs us a set of scales. There was one place that I read that a certain tarp size, and I can't remember what it was, but that tarp size weighed, those pounds equals tons per acre application. It's a straight up conversion. And I wish I would have saved it, but I didn't. So our tarp's 10 by 10, covers 100 square feet, is 1/435th of an acre. We collected 110 pounds on that tarp. Comes out to 47,000 pounds per acre. And because our test, that's going to probably show on the next slide, comes in at, or most solid tests gives you your numbers in pounds per ton. And so when we calibrate, we try and get, you have to get those two numbers to match or it doesn't do you much good. So how much nitrogen is applied on the sample that tests out at 12.4 pounds of nitrogen per ton, and nitrogen is the total nitrogen. You go through the math. We applied that 12 feet, or our previous slide said that we calculated out that we're applying basically 24 ton an acre times your 12.4 is a 300 pound application. And again, that 300 pound application at this point is not taking into account volatilization. Or, I mean, how many days is it staying out there? Are you disking it in? Is the windshield wiper going in your tractor because it's spraying back at you? I have seen that, especially when a guy's paying to spread manure. I mean, you get the benefits of the added organic matter plus the nutrient content. And when it costs them money, they want to do the most they can to get it in the ground. So that's kind of what I want to talk about. I have NRCS used to put out this publication that had pictures of different manure application rates, and oddly enough, I couldn't find it. And I think the reason was because they were taken on snow. And you guys all know on all your nutrient management plans says thou shalt not spread on frozen, saturated, or snow-covered ground. And one of the government's guidance was on snow-covered ground. But I couldn't find it. I tried. It took me 2 days, and I still couldn't find it. This is out of Kansas State. So I have five pictures with different application rates. You just want to keep a mental note of what.
Do you have a little pointer?
What's that?
Do you have like a laser?
I'm not sure.
Yes.
So the manure application. This is kind of hard to tell. Corn stubble, corn for grains. You got a bunch of the stalks in the ground, but there's your manure application right there.
You want to guess now?
Yeah, you can guess, and I'm going to tell you in a second. That's 40 ton of manure. This is beef waste, by the way, so it's going to have a slightly different characteristic than what you deal with. But as for a visual, that's about what a 40 ton application. That's pretty dry too. This is hard to tell. They hand applied this, so this was at a field day, and so the area was measured and the weight was measured, and so they did their best hand at doing it. So this is 10 ton application.
Oh, that looks like nothing.
Yeah, almost nothing. Again, right here is the area we're looking at, and that was 20. I should have mixed them up because this one's 30. Can you guess what the next one's going to be? 40. No, 40 was the first slide. This one's 50. This one's 50 ton. You know, in the past, I worked with a lot of people that they soil sampled and then they tested the manure and they said, I need to apply, and they went out and applied. And you asked them how much they applied, and they said, I applied 400 trucks to this field. And you're calculating that after the fact. It needs to be done before, so you need to understand what your application looks like. Some of the guys I worked with in Linden, and he was out there doing it enough. I had one guy that he would guess his manure content based off that Agros meter, and I mean he was pretty much right on. So with time, you're going to develop what your numbers are. Regulations say you're going to test them. Take them to where they're meaningful. Take them to where right before we apply them. If you take a sample this fall and you're using that sample for next spring, it's going to be different. Your application rates should change. So just be mindful of it. Lori does have that Agros meter. I think it's kind of rusted up. It's plastic and it's still rusted up. Because that thing does take, it's like bleach, like dry bleach, and you put it in there, and it's pretty volatile. But it's also pretty dang accurate. So, any questions?
How much is one of those meters cost?
$500 was the last time I saw it. And it comes with its own special chemical, which is Clorox bleach, which I'm pretty sure it is. There's a bunch of different in-field tests that you can do. To me, that one was the most accurate. If I was spending the money, I'd do it again with that one. At one time, there was a bunch of hydrometers floating around. Those only work at certain solid percentages, in the effluent. In our fourth pond down the road, it's probably not going to give us anything. But if we're applying out of the pit in the back of the barn, that's going to be pretty accurate too.